Okay, in this video, I'm going to talk about section 2.1, linear equations in two variables. A lot of this video, you've probably seen this content before in another algebra class that you've taken, but it is probably good for us to review and go over that. So we're going to start off when we talk about linear equations. Linear, that word linear means straight line. So we're talking about equations that have graphs that are straight lines. And really the most important feature of a straight line graph is its slope. That tells us a lot of information about that line. The slope measures how steep our line is, and that means how much the line goes up, rises, or goes down, falls, compared to how much it changes side to side. And I'm sure you've seen this formula sometime before. Sometimes we say that the slope is the rise over the run. The rise is the vertical change or the difference in the y values, and the run is the horizontal change or the difference in the x values. So for here, for example 1, we're just going to go ahead and apply that formula. If you get confused on plugging these values in, you might want to label them. There's our first point, x1 and y1, and there's our second point, x2 and y2. So when we go to calculate the slope, y2, watch those negative signs, negative 1/3 minus y1, negative 4/3, over x2, negative 3/2, minus x1, which is 11/2. If you're not feeling good about those fractions, grab your calculator, but these have common denominators, so they're not so bad. We can figure this out. We have minus a negative, so that ends up being plus. Negative 1/3 plus 4/3 is 2/3. Nope. 4 minus 1 is 3. 3 over 3 on the top. Negative 3 minus 11 on the bottom is negative 14 over 2. And those both reduce. 3 over 3 is 1. Negative 14 over 2 is negative 7. So our slope is negative 1/7. A negative means our line would be decreasing or going downhill. And 1/7 is not a very steep slope. That means it's going only 1 unit down for every 7 units over. Okay, so a downhill decreasing slope, but not very steep. We do have a bunch of different forms that the equation of a line can take, labeled here. The ones that we are going to focus on most are the slope-intercept form, y equals mx plus b, and the point slope form, y minus y1 equals m times x minus x1. And we're going to use those in these next examples. First up, our directions say find the slope and the y-intercept, if possible, of the line. Okay. When you're asked to find the slope of a line and you're given an equation, what we want to do there is we want to put the equation into slope-intercept form. Or another way to say that, or what we do in order to do that, is to solve for y. We want the y to be by itself, so we can have something that looks kind of like this form right here. So our first equation, it's a pretty little equation, y plus 2 equals 0. So if we want to solve that for y, we got to subtract that 2 to take it over to the other side. When we do that, we get y equals negative 2, which maybe you're thinking doesn't look exactly like this. It doesn't, but we can match it up. That's the same as saying y equals, notice right now, we don't have an x variable, okay? So that means m must be 0. The slope is 0 times x plus b. Our b is negative 2. Okay, so we don't usually write it like this, but if we wanted it to match up with the slope-intercept form, we could write that. And then we would see that our slope is 0 and our y-intercept, b is negative 2, so our y-intercept is the point 0, negative 2. And it just so turns out that specifically this line, y equals negative 2, is a horizontal line. Okay, if we went to graph that, it would just be a horizontal line at negative 2. Okay, next one is a little more what we'd see usually for this type of problem. Again, if we're asked to find the slope and y-intercept, we want to solve for y. So I'm going to start off here by moving the 7x over to the other side by subtraction. When I do that, I then have negative 6y equals 30 minus 7x or minus 7x plus 30. I like the x to be first, so it matches my slope-intercept form. Okay, then again, keep in mind, solving for y. So I'm now going to divide both sides by -6. Negative 7x gets divided by -6, and that becomes a positive 7x. Sorry, 7 over 6x. And then 30 divided by -6 becomes -5. Then we can just read our slope and our y-intercept right from the problem. Slope is the coefficient or the number in front of x. So our slope this time is positive 7 over 6. And our y-intercept, well, b is -5. So that means our y-intercept is the point 0, -5. Okay, next set, excuse me, next set of problems, it asks us to find the slope, intercept, and the point slope form of the line that meets the conditions given. So we're going to write the line twice. We're going to write in two different ways, the point slope form that I've highlighted here, and, oh, sorry, slope intercept form and point slope form. Yes. Okay. So number 4 says we want a line that has a slope of 2/3 and passes through the point 3, 1, okay? So if it tells us there the slope is 2/3, that's m, right? And it has to pass through the point 3, 1, so that is an x value and a y value that we've been given. Okay, so we can use that information to fill in our slope-intercept form of the line. Okay, y equals mx plus b. Well, I just said m is 2/3, so I'm going to fill that in. Now I want to figure out what b is, so I'm going to use this point they gave us up here. I'm going to plug in numbers for x and y so I can solve for b. So if y is 1, x is 3. Now I only have one unknown here, one variable, so I can solve 2/3 times 3. Those 3's cancel, and that simplifies to just 2. Subtract that 2 from both sides, and we get b equals -1. So we want to write the final equation. The final equation needs to have an x and a y in it. Y equals 2/3, that's our slope, times x minus 1, because our b goes at the end. The formula is plus b, but when your value is negative, it becomes a minus. So that is our point slope form. No, sorry, slope intercept form. It also asked for point slope. And there, we really just have to fill in the blanks. Point slope looks like this. Y minus y1 equals m times x minus x1. The plane x and y stay in your equation as your variables. The x1 and y1 get replaced by the coordinates of your point. So our point had a y value of 1. The slope it told us was 2/3. X stays because that's one of the variables in our equation, minus x1, our x value was 3. And this is the point slope form. We don't have to do any solving or figuring out values. We just need to plug the numbers into the correct places. Now that we found our equation, it wants us to sketch that graph. I would say I like to use the slope-intercept form to draw the graph. Okay. When using the slope-intercept form to draw a graph, start with your y-intercept. That's your starting point. So this graph has a y-intercept of -1 right there. That's our value for b. And then use your slope to find as many subsequent points as you need. So if our slope is 2/3, remember that's rise over run. Since it's a +2 to get our next point, we're going to go up 2 units and over 3 units. So we end up right here for our next point. And we can do that as many times as we want to draw a nice straight line. I think it's nice to do it at least twice. If we wanted to, we could back up and do it this way too. That gives us our line for that equation. Okay, next example. We need to find the equation of a line that passes through the points -6, -3, and 2, -3. So number 4 told us the slope outright, number 5 doesn't, but anytime we're asked to find the equation of a line, we must begin by finding the slope. We can't find an equation if we don't know the slope. So remember from the previous page, y2 minus y1, and again, if you want to label these, if that makes it easier, We can do that. Y2 minus Y1 over X2 minus X1. We do some simplifying, -3 minus a -3, so that becomes plus. That's a 0 on top and an 8 on the bottom. 0 divided by 8 is equal to 0. So the slope of this line is going to be 0. So if we start with our slope-intercept form, y equals mx plus b, and we put 0 in for n, m. And maybe you know what b is. You can tell just from looking, but if you don't, that's okay. Do what we did in the last example. Choose one of those points. It doesn't matter which one. Put in x and y, and we'll be able to solve for b. So I'm going to use the first point. So the y value is -3. The x value is -6. 0 times -6 is 0, so we get right away that b is -3. So our equation is y equals 0 was our slope, plus b. So you could write plus a -3, but we would clean this up a little bit. We don't usually write that 0x in there when we're writing our equation. So our line is just y equals -3. It is, again, a horizontal line. And when it's a simple equation like that, y equals -3, we don't really have the different forms of the line because it is just a basic horizontal line. So at y equals -3, our graph would look like this. And that's it for section 2.2. I mean, sorry, 2.1. Where were we? 2.1.